In this video, I'm going to be going through exercise 12. It talks about the ideal gas law. So exercise 12 says a sample containing 0.35 mole of argon gas at a temperature of 13 degrees Celsius and a pressure of 568 torr is heated to 56 degrees Celsius and a pressure of 897 torr. Calculate the change in volume that occurs. So let's see what important information we have. In the first place, we are told we have 0.35 moles of argon, but we're not told that that changes from before to after. So that's not actually an important piece of information because that's just how much we have throughout the whole problem. So it's not going to affect our calculations because it's not changing. But we're told that we start at a temperature of 13 degrees Celsius and we end at a temperature of 56 degrees Celsius. So our temperature is changing. And then we're also told that we start at a pressure of 568 torr and we we change it to a pressure of 897 torr. And we are looking for our change in volume. Okay, so we're really concerned about temperature, pressure, and volume. Those are the only three variables that are changing throughout this problem. Now, if I just think about it, if I am increasing the temperature, I'm heating something up, I would expect my volume to increase. But if I am increasing the pressure, making the gas more pressurized, hit those walls harder, I would expect a decrease in volume. So it's hard to know whether my volume will increase or decrease. I do know a lot about the relationships between pressure, volume, and temperature, though. I know that pressure, P1 times V1 over T1 has to equal P2 times V2 over T2. Okay? And if you're unsure of how I got this, I want you to think about the ideal gas law. If we have PV equals nRT, okay, if I change this and I say pressure 1, volume 1, moles 1, and temperature 1, my R is a constant, so it doesn't really make a difference. But if I solve for R, I would get R equals P1V1 over N1T1. Okay, so if I have the same ideal gas law, but for the after it changes, then I would have P2V2 equals N2R T2. So this is after it changes. These are all my after I heat. This is my pressure, volume, moles, and temperature after I heat. So again, if I solve for R, I would have P2V2 over N2T2. Okay? And I want you to notice, I have R here and I have R here. That is a constant. They are equal to each other, which means that these two equations also are equal to each other. So I'm able to set them equal to each other. So I could say P1V1 all over N1T1 equals P2V2 all over N2T2. I also know that, again, my moles is 0.35 both before and after. So I can just erase my moles because they are equal. They are not going to affect this relationship. And now I have my relationship here. So now it's time to plug in my numbers. So I'm told that I start with a pressure of 568 torr and a volume of, I'm not told that, so I'm going to leave it as V1. I don't know my volume. And a temperature of 13 degrees Celsius. Remember, you must convert Celsius into Kelvin. We're told that after we heat it, our pressure changes to 897 torr. Again, we don't know our volume, so our V2 is a mystery. And we heat it to 56 degrees Celsius. Make sure you convert your Celsius into Kelvin. Okay, so now I can solve for my V1-V2 relationship. So when I rearrange this equation, I'm just going to move my volume 1 to the other side. So I'm going to divide by V1 on both sides, and I will move this to my left side. So I will multiply by the reciprocal of that relationship. So then I get 0.73 equals V2 over V1. So what this means is, first off, it means that my volume 1, my initial volume, is bigger than my volume 2 because this number is smaller than 1. It also means that if my V1 was 100, my V2 would be 73 liters. So a good way of thinking about this is my V2 is 73% of V1. And that would be how much my volume changes before and after heating.